Okay, we did example 1A and 1B on page 126 last time. We did the hypothesis test for two proportions. We did the corresponding confidence interval. To jog our memories, I want to write up some of the highlights of those. Page 126, if we just list what the 5 steps were, which I was going to do steps 1 through 4. The claim was that P1 is less than P2. Is that what our claim was? Comparing those two proportions. We did a 2 prop Z test and we got a test statistic of, someone help me out?
2.25.
2.25? Negative 2.25. And a p-value of
0.01.
0.12. And what was our alpha? Was it 0.05?
Yeah.
So step 4, then we decided to reject H0. And then we had the whole conclusion written out, evidence to support the claim. And so forth. I'm not going to write out the whole thing because we already did this problem. And then on part B, this was 1A, example 1. Example 1B was now do the corresponding confidence interval. So because we did at the very end of class last time, I want to make sure we remember what happened for the corresponding confidence interval. What did we do? We did a 2 prop Z test is what we did here, do the test. We did 2 prop Z int. So the subtle difference, if you're doing a test, you put the word test on the end. If you're doing a confidence interval, you put the word int on the end. So we did 2 prop Z int. And it asked us for the same inputs as we put in for this problem over here, the x1 and the n1 and the x2 and the n2. But then it asked for a C level. If you're looking at 2 prop Z in. Who remembers how we determined the confidence level? Yes, Phoebe.
You just subtract the alpha level, and if you have the 2 tails, then you have to multiply it by 2 and subtract that.
Okay, so we had to use the alpha from part 1 and create these tails for the confidence intervals. So I'm going to draw the picture. If we were doing the test over here on the left, it was a 1-tailed test, a left-tailed test, so if we were finding critical values, this would have been our critical region to do this test. So the corresponding confidence interval has the same size tails. Tails plural. Sorry, go ahead, Kristen. Yeah, so we had 0.05 in this tail, but to be a confidence interval, remember there were always 2 tails for every confidence interval. So this is where I created another matching tail. It has to have 2 tails. So this one is also 0.05. We don't split this in half, because that changes the size of the original tail. The tail has to go with this problem. And so therefore, what's left, these men?
We can explain why it's 2 tails and it's not because it's...
Because we're asking for a confidence interval, and every single confidence interval is 2 tails. You take the middle and you add and you subtract your error. Every confidence interval is 2 tails. So that's the tricky part, is our test was not 2-tailed, but to make a confidence interval, we had to make it 2 tails. So what's left in the middle? 0.90. And that was our C level that we used for this problem. So some of you already started working ahead and working on the 9.1 lab, and I saw you last week in the math lab. And the problems do exactly this. They ask you to run the test And then that's part A, and part B is do the corresponding confidence interval. So you have to figure out what that confidence level is. If our test had started off as two-tailed, if we already had two-tailed test, we wouldn't need to create another one because we already have two tails, and we would just use the values from there. But if you don't have a two-tailed test, you have to create one to get your confidence interval. And what was our confidence interval here? What were our numbers? I know they were both negative.
Negative 10.35
.1035.
and .0164.
Thank you.
And that's negative as well.
Oh, yes, thank you. They were both negative. And what was in between there?
P?
Not just P.
P1, P2.
P1 and P2. What about P1 and P2?
P1 minus?
P1 minus P2. Anytime you run a confidence interval for two populations, it's giving you the difference in those two populations. In this case, the difference in the two proportions. Similar to if I took me and Kirsty and said, hey, how different do you think our ages are? I'm not asking her how old she is and how old I am. I just want to know what is the difference between our ages. Somebody give me a guess. If you had to guess the difference between my age and Kirsty's age, don't worry, neither one of us will be offended, hopefully. I won't. If you had to guess the difference between my age and Kirsty's age, who wants to guess? Anybody? I need a couple guesses.
15.
15. So you think there's a 15-year difference? And not that anyone will be offended, but I'm assuming that you think I'm 15 years older than her. Is that true?
Let's do a random number up there.
Okay. Well, it's important that I know if you think I'm older or she's older.
Well, you're older. Yeah.
Okay, so
That's
he thinks
absolutely-
I'm older by 15. I like it. Anybody else think it's a different number? More or less? No one will be offended. I need a couple more numbers.
20.
Me and Kirsty. She thinks there's a 20-year difference. Think I'm older too? Okay. So she thinks I'm 20 years older than Kirsty.
10.
10. So I hear numbers be 10, 15, 20, so somewhere between 10 and 20 years older, you guys seem to think. We agree with that statement? That's what I'm hearing. So tell me what would happen if I took Kirsty's age minus Jill's age. What are we saying? It'd be a negative number. Why would it be negative?
Because we assume the case law.
Because everyone's thinking that you're younger than me. She looks really good, you know, so she must be younger, right? Or maybe I just look really tired, so I look really old, I don't know. But we think she's younger, so we agree that's going to be negative. And it's somewhere between 10 years difference and 20 years. Kevin will split the difference in between. So what we would say is the difference here would be somewhere between negative 20 and negative 10. Two things in this interval. They're both negative because we're pretty sure that when you subtract her age minus my age, you're going to get a negative number. And how negative, we aren't really sure. It's somewhere between 10 years difference and 20 years difference. We think. We don't know for sure. We're not going to actually check. But notice that these negative numbers don't represent our ages. It's the difference if we were to subtract our ages. So same thing over here. These negative numbers don't represent the proportion of students who use drugs now versus 93. It's what's the difference between those two proportions. If I was to write a sentence for this one, we think that Kirsty is 10 to 20 years younger than Jill. Do we agree that's what this says?
Yep.
We wrote a sentence for this last time. We're 90% confident. Which one was P1, the 1993 students?
Yeah.
That the proportion of students who use drugs in 1993 is, what could we say? I said it last time. Might have changed my words a little bit this time.
Is 1.64% to 10.35% lower than it is now?
Why did we say lower? Because the answer came out negative when we subtracted. If you subtract and get negative answers, that means that first number must have been smaller. Same thing with my age and Kirsty's age. You take hers minus mine, it's going to be negative. What would happen if we took my age minus hers?
Be positive.
It better be positive, right? It'd be positive 10 to 20. So it tells you that that first one is smaller or bigger than the second number. So confidence intervals actually give you more information than the tests. The test just told me that we do have evidence that there was less drugs in '93 than there is now. This tells me how much less. Somewhere between 1.6% and 10.35% less. Okay, questions? All right, we're going to move on then. Moving on to page 127. Example 2. Now instead of asking students if they use illegal drugs, we're going to ask married people if it's wrong to have an affair. All kinds of interesting topics today. Yes.
Are we going to have to identify the HO and the H1?
That's a really good question. She says, do we have to identify the HO and the HO1? Let's finish reading the problem, then I'll go back to answer that. So we took a poll. We're asking people if it's morally wrong for married people to have an affair. They surveyed some women, and a certain number agreed with that statement. They surveyed some men. And notice the directions for that problem in the last sentence. Construct a 95% confidence interval estimate for the difference between the two population proportions. Nowhere in there does it say test a claim. We agree with that? If it doesn't say test a claim, you're not doing a hypothesis test. You don't have to do the 5 steps. You don't have to write H0 and H1. You don't have to get the test statistic and the p-value and all that. All you have to do is get the confidence interval.
So you just go right to 2 parts.
So we can go straight to 2 prop z int. Why is it 2 prop z int?
There's 2 samples.
There's 2 samples from 2 different populations. So in this one we can go straight to 2 prop z int. This is from page 127. If we go straight to 2 prop z int, what are we going to input in there?
What are our proportions and
Yeah.
our P1s and P2s?
Yeah, well, actually, instead of our P's and P1s and P2s, it's going to ask for the X's and the N's.
Yeah,
The first
same
X will be
thing.
347.
1 second. Yes, Christiana?
How do you know on the test if it's 2 prop C or 2 prop C test?
If it says construct a confidence interval, that word interval tells you you're doing an int. If it says test the claim that such and such, then it's a test. So it all depends on the directions. If it tells you to test a claim, you're doing test. If it says to get a confidence interval, you're doing an int. So I think what you're trying to say, Kevin, is let's distinguish which population is which.
Yes.
That's what you were, I thought you were talking about P's, but I think you were just talking about who's who. Men and women. Which one do you want to be women and men? Does it matter?
Yeah.
Yeah, it matters, so we need to decide.
So women would be P1.
Okay, so we'll let women be the first group and men be the second group. It doesn't matter which one is which, as long as you decide which one is which and you stick with it. So we're letting women be the first group. So then when we go into 2 prop z int, it asks for x1 and n1, which were
X1 and
341 for X.
347.
Oh, 347, yeah. And then 386 for N.
Because we had 386 total women, and this is how many of them said yes to our question. And then it wants x2 and n2,
305,
305
and 359.
out of 359. Those are the same x's and n's like we saw before. And the only other thing it wants is the sea level, which they gave us in this problem, of 0.95. We don't have to figure out what it is because it's not tied to a test. It's just find the confidence interval. By the way, if you don't want to use the 2 prop z int, you could use that pretty formula in the middle of the page, middle of the problem there. I'll show you after class for fun if you really want to use it. So we get that all typed in there? What do we get? What are our numbers?
0.00172.
0, 0, 172,
And 09704.
09704. Again, it's P1 minus P2. The confidence intervals will always give you the difference in the proportions.
So how do we interpret that?
Yeah, that's the important part. How do we interpret this?
You make it percentages, right?
If you turn them to percentages, it helps. So this is like 0.17%. Barely more than 0%, but it's slightly positive, less than 1%. What's this one? 9.7%. First off, my question for you is, are my answers positive, negative, some of each? It's positive. So when I subtract these two numbers, I'm getting some positive number, which tells me what about these numbers? Which one's bigger, which one's smaller?
P1's bigger.
P1's bigger?
P1's
P1's smaller? If I take two numbers and subtract and the answer comes out positive,
P1's smaller.
let's do some practice problems.
P1 is
7 minus 10,
P1
8
is
minus
bigger.
4, 12 minus 6, 10 minus 5. If the first number is smaller than the second number,
Negative.
we agree the answer comes out negative? This one comes
That's
out
positive.
positive?
Now it's positive.
Oh, these all came out positive.
They're all positive.
Here, make it a 15. There we go. The answers come out negative when
P1 is smaller.
P1 is smaller than P2. See that, Brian?
Yep.
And they come out positive when the first number is bigger. So if my differences are positive, can I erase this? Just like a little guessing and checking if you're not sure. My differences are positive, so what does that tell me? In words with this problem?
P1 is bigger.
P1 is bigger.
Okay, but I don't want to, what's P1 in words?
That women,
She doesn't know how to say it. Something about women and P1.
They agree
Yes.
that it's morally wrong.
Women think it's morally wrong?
Mm-hmm.
You're close.
More
the majority of.
More women, not even the majority of women. More women think it's morally wrong than men. Because when we say P1 is bigger than P2, this proportion is bigger than this proportion. The proportion of women who think it's morally wrong is more than the proportion of men who think it's morally wrong. Let me write it this way. So women have a higher percentage than men who think it's morally wrong.
Women are more likely to think.
Women are more likely to think it's morally wrong. That works too. Because remember, P's are proportions, they're probabilities, they're percents. You can use any of those three words in your conclusion and that would be clear. Women have a higher percentage than men who think it's morally wrong. He used women are more likely to think it's morally wrong. You could say the proportion of women who think it's morally wrong is higher than the proportion of men. How much higher? How much higher?
9.53, the difference, or?
No, we don't, the difference is some number in between here. Kind of like going back to me and Kirsty, we don't know how much older than her I
Oh,
am.
just a, okay.
We just can
floating
talk
rate.
about a range.
Okay.
So the same thing here, we don't know how much higher. It's somewhere from 0.17% up to maybe as much as 9.7% higher. But we don't know exactly how much higher it
Oh,
is.
okay, I get it.
The whole point of tests and intervals is you don't know what it is for the whole
There's no
population.
exact number. it's
There's
just
never
like-
gonna be an exact number, it's a
Oh, okay.
range. Now, you're gonna see a lot of problems here with confidence intervals where they ask you if 0 is in your interval. So let's say I decide to pick on Carrie and Jenna now. And we wanna know the difference between their ages. Most of you can only see the backs of their heads. So you're gonna predict the difference in their ages from the backs of their heads. When I look at them, I think maybe Carrie's like 1 year older than Jenna. That's my guess. Anybody want to have a different guess? They won't be offended, I swear.
I'm not sure which two they are.
Exactly, so let's just guess then. That's my point.
I don't know, 3 years difference with Jenna being older.
Okay, so maybe Carrie's 1 year older, maybe Jenna's, so I'm gonna take Carrie minus Jenna. Carrie with a C, not a K. So I think maybe Carrie's 1 year older, so Kirsty's over there thinking maybe Jenna's 3 years older, so that'd be a -3, right, if Jenna was the older person? Anybody else wanna guess? We don't even know them, can't see who they are from the other side of the room. Yeah, what do you think, Christiana?
I think Carrie's 2 years older than Jenna.
So you think it's 2 years older? These are just guesses for if we were to subtract. The positives come out saying because Carrie was a bigger number than Jenna. The negatives come out from saying that Jenna was a bigger number than Carrie, because we don't know, we're guessing. So if we take these, my interval would be somewhere between -3 and +2. The lowest and the highest numbers. Do we agree with that? Is 0 in between here? 0 in between there? What would it mean if those two had a difference of 0? That they're the same age. So you're gonna have a lot of questions where they say, is 0 in your interval? And if the answer is yes, what that means, it's quite possible that they're exactly the same, which means there's no evidence of a difference. He just light bulb went on over his head. Could be the same. So we say there's no evidence of a difference.
So 0's in your interval.
Yes, if 0's in your interval, it's saying essentially that those two whatevers you're subtracting might be the same, which basically says you don't have any evidence that they are different from each other. We're going to see some of those coming up, but they're not in this section, so I want to talk about it now. Difference. Or a different, no evidence of a difference. Because basically with your confidence intervals, you have two options. You're going to say one of them's more than the other one by a certain range, 1% to 10% higher. Or you're going to say one of them's lower by a certain range. Or you're going to say there's no evidence of a difference. These ladies are so close in age that we can't tell who's older, so they might be the same for all we know. So we don't really have evidence of a difference, where there didn't seem to be any discrepancy in deciding that I was older than Kirsty. So I'm definitely older by a certain range. There's no doubt that she and I might be the same. So we do have evidence of a difference in that case. Questions? Okay, let's do that last example. Example 3, now we have the Hawkeye instant replay system for tennis. Oh, by the way, the conclusion that the interval suggests is what I was writing here. We talked about different ways to write it. So the Hawkeye instant replay, men are challenging the referee's calls, and women are challenging the calls. Now we're using a .01 significance level to test the claim that men and women tennis players have different success rates when challenging calls. What is the problem asking me to do?
Test the claim.
Test the claim. So I have to go through all 5 steps of my hypothesis test. I gave you that information down here about H0 and H1, but on an exam it's up to you, kind of like what Christiana was asking earlier, to read the problem and say, am I asked for a confidence interval or am I asked for a test? And because it's a test, we have to go through our 5 steps. So example 3. We have an alpha of 0.01. Alpha equals 0.01. What is the claim?
Did they have different success rates?
Different success rates. What's not equal? She's over here telling me they're not equal. What's not equal?
The success rate?
P1 and P2. A success rate is a proportion or a probability. The proportion of successful men challenges compared to the proportion of successful women's challenges. Let's let number 1 be men this time. They gave us men first, right?
Yeah.
Different means not equal to. So this is the claim. So what's H0? P1 equals P2. And because they're asking me to test a claim, I'm going to use two-probability test. Because I'm testing a claim this time. And again, it's going to ask for x1, n1, x2, n2, and then we're going to choose a not equal to claim when we get down to the bottom there. Lost my page. So for men, I have 201 out of 489. And for, oops, I wrote x2 twice, just saw that. N2. For women, 126 out of 350. If you're reading my problem carefully. So the step 1 is to write your hypotheses. Step 2 is to get our test statistic. Did we get one yet?
Yeah.
Say again, Kevin?
1.49.
We agree with him? 1.49. And we should have a p-value.
0.135.
Say again?
0.135.
0.135.
Don't you just take that and put it next to the alpha and see which one's bigger?
Yes. So if we're using the p-value method, we're just going to compare that to our alpha to decide what to do for step 4. That's the easiest way to get to step 4. Our alpha was 0.01. This is definitely bigger than that.
So you reject the claim.
Ooh, we fail to reject. We only reject when the p-value is smaller than alpha. So we fail to reject H0. And then the conclusion is the important part. This one was our claim. We failed to reject this one. We're stuck up there. We couldn't reject it.
He's good.
So there's not sufficient evidence?
So we don't have sufficient evidence. Perfect. What were you asking me, Kevin?
I was just talking out loud.
Oh, okay. We don't have sufficient evidence to support our claim, right? We can't support it because we didn't reject this one. Support the claim that men and women have different success rates. So we don't have any evidence of a difference, is what we're saying. Questions on my 5 steps? I want you to add one more little problem on the bottom of this page. I want the corresponding confidence interval. The confidence interval should tell us the same thing. See if we can squeeze it in down there. What am I going to do if I want the confidence interval for this problem? 2 prop z int, but we have to figure out our C level. It's 2 tails I'm hearing back there.
So we can create another one, right?
Well, if this problem already was 2 tails,
0.01.
my .01 was already divided into 2 tails. Right, that's what we did when we have 2-tailed tests. So what's the area in each tail if I had .01 and it was 2-tailed? 0.05? You take that .01, you cut it in half.
Does that mean the middle would be 99.9?
So the middle would be 99. So because we started with a 2-tailed test, our 2 tails already added up to .01. So the only thing I have left for inside here is .99. I didn't need to create the extra tail because I already had 2 tails. So then when you want to go into 2 prop z int, all you need to tell it is the .99. It has all this other information still in there for you. Must be time to go. Must be time for a break. Let's put these numbers up here to interpret, and then we can. What do we get for our numbers? Should be a negative number here. Yeah, be a negative?
-.0364.
And a positive number over here?
0.13852.
We agree with his numbers? Notice the difference goes from negative to positive. It goes from negative to positive. I hear you said. So 0 is in between there. Because 0 is in our interval, that's one of the possible differences is 0. What does that tell you about P1 and P2?
It could be the same.
They could be the same. Could be the same. So my conclusion would be, we have no evidence of a difference. In the success rates. Which is the same conclusion we had over here. The confidence interval on the test should tell you exactly the same thing. We had no evidence of a difference when we did the test. We still have no evidence of a difference. This says men might be lower by 3.6%, or they might be higher by as much as 13.8%. It's hard to tell which one's lower and which one's higher. 0 is a possibility. Just like when I was trying to talk about Jenna and Carrie's ages. One might be younger, one might be higher. They might be the same. Yes.
So 0, we're concluding that in 0 wasn't in an interval, would we say that they aren't the same, that there is evidence, like the
Yes,
opposite?
exactly. So if 0 was not in our interval, let's say these were all positive. This was positive to positive. Since 0 is not in the interval, they definitely are different. And if they were positive, that means that the P1, which was men, had a higher success rate than women, if they're positive. And if they were both negative, it would have been lower. So your answers, the only 3 possible answers are the first one's higher, the first one's lower, or there's no difference. Those are the only possible things you could come up with. We will be seeing more of these in the next section. Okay, we good with that one? Let's go ahead and take a 10-minute break from here. I'll pass back the rest of these quizzes, and then we'll go on from there. Flip over to page 132,
What's that?
page 132, section 9.2.
We're almost done.
We're almost done. There's hardly any pages left in that little thing.
Yay.
Yay. Yeah. Not much more we can cram into our brains, right? And once you get to page 132, pull out your packet and open it to page 2. So you're on page 132, and you're looking at page 2 here. So we're all together. So chapter 8 was pretty much this first column over here. Hypothesis test about proportions, means, standard deviations. Hey guys.
Hey, class started.
Hi. If you want to, you can talk outside, but I was trying to focus on this. So chapter 8 was on this first list. Chapter 9 is in 2 different places. So I want to talk about this. When you look at, I have to turn this around. When you look at the the second 2 columns here, chapter 9 is kind of spread out when you have 2 proportions or 2 means. So if you start off with the middle column, at the top it talks about what to do if you have 2 proportions. So if we have 2 proportions, that's what we were doing last time with the 2 prop Z test and the 2 prop Z int. Oh, sorry, 2 prop Z test, there's no int there, I'll talk about that in a minute. But if we're comparing 2 proportions, that's what we were just doing. What we're about to do in 9.2 is talk about what to do when we have 2 means. So I'm in the middle of this page. And if you look through there, you can use that pretty formula or skip to the bottom of it. It tells you that you can do a 2 SAMP t test. Right? That's what we're about to do. But there's nothing here about confidence intervals. 2 prop Z int or 2 SAMP t int that we're about to do. So it's on another page. But before we go to the other page, what I want to point out is it's identical to what you see here, except you just have to swap out the word test for int. So you don't really need to go looking on another page. If you have 2 proportions and it's asking for an interval, instead of 2 prop Z test, you'll do 2 prop Z int. Or we're about to do the 2 SAMP t test, and then you would change it out to 2 SAMP t int. But if you would like to look at the whole separate page, it's back on the front. Yes, Christine?
You said that you'd only change it to int when we're looking at the confidence interval, right?
Yes. Yeah, but those also are on the front page, just in 2 different places, and to me it's overwhelming to look in 2 different places. I'd rather just look in the one place and know that when it says interval, I'll put int, and if it says test, I'll do test. But if you look in the right-hand column of the front page, page 1, it has all of the 2 population confidence intervals over here. It has the 1 sample at the top, the 2s are at the bottom. So the 2 prop Z int is down there for 2 proportions. The next one down is 2 SAMP t int, which we're about to do. The next one down is called matched pairs. And notice they even put the P1 minus P2 inside their interval there, the way I've been writing it at the top, the very top of the 2 proportions. I erased all my examples. See where it says P1 minus P2? We're about to do mu1 minus mu2. So this helps if you want to make sure you're writing the notation correctly. So chapter 9 is kind of spread out. Some of the intervals are on the front page, the tests are on the second page. Okay, so now let's go into page 132. So page 132 is all about testing claims about 2 populations again, but now they're asking about 2 means. Like the average age of LMC students versus the average age of San Francisco State students. Are those means the same, or are they different? Is one older or younger? So those are not a proportion, it's a number that you can calculate the mean, the sample means, and decide what to do with the populations. So just like we did before, sometimes our tests are about proportions, sometimes they're about means. And before in chapter 8, what did we do with means? What kind of tests did we use in our calculator? If we had a test about a mean. Silence. You could use your packet to answer this question. If you're testing a claim about a mean, what did we use? No, if we had a test about a mean. Sometimes we do the Z-test,
It's a measure of center.
And sometimes we had a t-test. Those were measures of center.
Yeah.
Well, how did we decide between z-test and t-test?
Whether there's sigma still?
Whether or not we knew sigma? So here's the good news. When you have two populations, you almost never know what sigma is for both groups. So we don't ever do a two-sample z-test. It's actually in your calculator. We will never be using it because you won't ever know sigma. So when you have two samples and you're testing means, you don't have to choose. It's always going to be a two-sample t-test every time, which is what it says on your packet there as well. When you have claims about two means. Or you can use the pretty formulas, which we'll do for fun during my office hour when you want to. The line will be long today, I'm sure. Okay, so let's look at example 4a. We've got the heights of a simple random sample of 9 supermodels. And these simple random sample of supermodels have a mean of 70.0 inches. How tall is that? Almost 6, it's like 5'10". Their average height is 5'10", and a standard deviation of 1.5 inches. The heights of a simple random sample of 40 women who are not supermodels have a mean of 63.2 inches. That's like 5'3" and some change. And a standard deviation of 2.7 inches. We want to use a 0.01 significance level to test the claim that the mean heights of supermodels is greater than the mean heights of women who aren't supermodels. So just from the sample, it sure looks like they're taller, because the sample mean is bigger than the other sample mean. But the question is it enough of a difference to say that they definitely are, on average, taller? What are my two populations?
9 and 40.
I didn't hear what you said.
9 and 40.
No, just the two groups I'm looking at.
Supermodels.
Supermodels,
And women who are not.
yeah, the rest of us. Supermodels and non-supermodels. Is that even a word? It is now. You can introduce yourself at a party. Hi, I'm Jill. I'm a non-supermodel. People probably would have figured that out. We made that word up. So those are our two groups. What is the claim?
The mean height of supermodels is greater than the mean height.
The mean height of supermodels, she says, is greater than the mean heights of non-supermodels. How do I write that? Mu. Kirsty the only one awake today? I'm glad Kirsty's awake. Leilani's like, yep, she's the only one awake. I'm letting her speak for me. Does everyone else agree it's a mu?
Yes.
Yeah, mu? The mean for the first group?
70.
Wait, I don't know what the mean is for that group. It's the population mean. What's the claim? I'm trying to write the claim. Someone besides Kirsty, because she's all over this.
Yeah, it's equal to me too.
Equal? That's not the claim though. I want to write the claim first.
Greater than the.
The claim is the mean for the first group. You guys are awake now, hooray. Is greater than the mean for the second group? Yeah? A couple of us, we're waking up. We like it. That's our claim. Is that H1 or H0?
That's H0 or H1.
H1, because it doesn't have an equal sign in it. But now it's about a mu, not a p. It completely matters if you write P1 versus P2 or mu1 versus mu2. Proportions are different than means. And if you're trying to use your packet to decide what to do on a test, if you write P, you start looking up what to do for proportions, you're going to be doing the wrong thing. It's so important to have the right symbols in there. So H0 would be equals. So once you have your claims written, then it's really a process of elimination and relying on this if you need to. And you're flipping through here and you're on page 2 and you're like, okay, I've got two different things and I've got two means, what should I do? And this tells you what to do. Right, but we've got two means. We have independent samples written there. Let's talk about what that means, because next time they won't be independent. The supermodels that are in their sample are not related in any way to these non-supermodels. It's not like they got a supermodel and each one's mom, right? here's a supermodel and here's her mom and here's her mom, her sister or something. They weren't tied together in any way. They were two completely different samples. Dependent samples might be like husband and wife pairs. Like here's a husband and here's his wife. Those are two, there's men in this group and women in this group, but they're related in some way, so those wouldn't be independent of each other. But in this case, they just grabbed one group, grabbed a different group, and they're not related anyway. That's what we're talking about for all of this section. We'll talk about how they're dependent next time. So we're gonna go in and do a 2CMT test. We all see where it tells us on here to do a 2CMT test? What does it want from us?
Excellent.
X bar 1, right?
Oh, yeah.
X bar 1 means, this is the mean from the first sample. Put the problem down. What was the mean? 70.0? Does it write SX1?
SX1.
That means standard deviation from the first sample? 1.5? So same stuff we've been doing all semester long. Then is X2 next? Sample mean for the second group and a standard deviation for the second group?
N1.
Oh, N1. Thank you. You need to know how big your samples were. N1 was,
40.
oh, careful, there were only 9 supermodels.
9, yeah.
Gotta read carefully, and those were the supermodels. That was a 9. The 40 is the next group. So then we do the next group. The mean, the standard deviation, and the sample size, which were 63.2, 2.7, and 40. Why do you think the sample size was so much bigger for the non-supermodels?
Because there's a lot more of them.
Yeah, there's a lot more of them. They're easier to find, right? If you want to go out and find out the heights of non-supermodels, a lot easier to find them than the other ones. Track down the other ones. You don't have to go to Milan or something on some runway. Find them. And what's the last thing it wants?
Sample size of the second group.
I got the sample size. What comes after that?
Greater than.
It wants the greater than. And then there's the next thing where it says pool.
Yeah, what the heck is that?
Yeah, what the heck is that? The good news is, what the heck of that is we're not going to be using it at all. There are times when you pull your samples together into one giant sample and times when you don't. But for us, it's always going to be a no. And it even says here on your sheet where it says pooled, say no.
Where's that?
So right underneath where it says 2CMT test, see where it says pooled no? And right in the middle of your packet there? So it reminds you, it'll always be no.
Oh, I meant, oh.
Learn to love your packet because it tells you what to do. So pooled is always no for us.
So,
Anything else it needs?
no,
So what should we get next?
get our key, test assistant.
Calculate. And we get our test statistic, hopefully, which should be a T. We're in the confidence interval instead of the test, Jenna? Are you good now? Okay. What's our T?
10.34.
10.34. Our calculator should also give us our p-value.
Which is 0.
0 plus.
Why do we know it's 0 plus?
Because it's standard, the scientific notation.
Yeah, tell me what it was in scientific notation.
It's 4.03 with an error of 10, negative 10.
You gotta know what that means. We've had this conversation a couple times now. Remember that the p-value is a probability. It has to be a number between 0 and 1. So the second you see that 4, you should be going, wait a minute, that can't be a p-value. But it is, because it really means 0.000000004, which rounds to 0. So what's that tell me to do?
Reject.
Reject the H0, because anytime our p-value is smaller than alpha, definitely less than 0.01. That's a 0.01, looks like a D. 0.01. So we reject H0. And if we reject H0,
We're gonna support
There's a question.
we have evidence to support the claim, Ariana saying. We agree with that? Because we rejected H0, we have evidence to support this claim. We have sufficient evidence to support the claim that the mean height of supermodels is greater than the mean height of women who aren't supermodels. Questions? Why do we do 2 CFT test?
Because we have 2 meetings.
Because we have 2 means in our hypothesis. Our claim has 2 means. When do we do a regular t-test? Good question.
Because we won't ever know the standard deviation of populations.
That's true for the 2 CFT test and the regular t-test, but my question is, when would we, what kind of claim would we have had just to do a regular t-test? If we only had 1 sample with a claim about the mean. So it matters if you've got 2 samples or 1, because it changes what to do. Now, so our conclusion tells us that what about these supermodels? On average, they're taller than the rest of us? We agree with that conclusion? Those are my words. On average, supermodels are taller than those of us who aren't. So the follow-up would be, well, how much taller? On average, they're taller, but how much taller? That's where the confidence interval comes in. That's where 4B comes in at the bottom of the page.
So we use your test statistic.
We're not going to use the test statistic, we're going to use the significance level and the same data to get the confidence level. And mine
Yeah,
is
but what's the relevance of the test statistic?
the relevance of this 10.34,
It
Yeah.
shows us where it falls,
Yeah.
if it's in the critical.
That's when we
range.
use it, right? Just for that.
not for the confidence interval, no. The test statistic just tells you that if 0 is here, this is like 10 standard deviations away. It's way the heck out here, which means the area in this little tail is some tiny number. So the test statistic actually goes with the test. The confidence interval says, okay, let's use this data now and come up with a range of possible values for how much taller are these supermodels. It doesn't actually use that T. It comes out in the formula if you were doing it by hand, but it doesn't actually show up for us. So we want to do, if you look at the bottom of example 4, using the data, did yours say data or date? Mine says use the date. Yeah. Using the data from 4A, construct the corresponding confidence interval estimate for the difference between the mean heights of supermodels and the mean heights of women who are not supermodels, and then we want to interpret it. So we're going to do a 2 CFT int. And when we go into 2 CFT int, because it's asking for the interval, it should be asking for all of this again. Isn't it?
Yeah.
And it also asks for
Sea level.
sea level. Sea level. Better draw the picture. The original test was what kind of tails? Left, right, two-tailed? The original test.
All right, Taylor.
Right tail? Greater
That's
than right
greater
tail?
than,
With an alpha of 0.01. So I'm gonna draw the picture that goes with that test. It was right-tailed with an alpha of 0.01. That's the picture that goes with that test. But if I wanna do a confidence interval, what do I need to do?
Split it.
I can't split it because this has to stay at 0.01 because it has to go with my test.
Would you subtract it from 1 to find the area of the left?
Not quite, I gotta do something else first. Somebody else said something, was it you, Brian? Yeah, Amy? I have to make this other tail and have two tails of 0.01. Remember from creating that matching tail? If you don't have a two-tailed test and you're asked for a confidence interval, you have to create that other tail that's the same size as this guy.
so confidence intervals have to have two tails.
Yes, every confidence interval has two tails.
So that way, so that
Yes,
would be easier.
Christiana.
So if it was like equal or not equal, then we would divide answer one with two
Yes, then
sides?
it would have already been split up into two tails, yes. We did one of those earlier. So what's my sea level going to be now then?
0.99.
98?
Careful, I got O1 here and O1 here.
Yeah.
So it'll be 0.98. So the corresponding confidence interval is one of the trickier things because you have to sometimes create that extra tail, sometimes you don't. So it's a 98% confidence interval that corresponds to the same test. And what do we get?
5.1483. And 8.4517.
8.4517?
Yeah. No zero.
What are those?
The critical value?
They're not critical values. They're the edges that describe my interval, but what am I looking for an interval for?
The difference in height.
Aha, the difference in the mean heights. He's so
So that's the
close.
minimum and the maximum?
But what do I write for the difference in the means?
The mu.
The mu.
Mu1 minus
Mu1 minus mu2. So if you take the average height of a supermodel and you subtract the average height of the rest of us, the difference is somewhere between 5 and 8. What do these numbers represent?
Inches.
Inches. This is actually about 5 inches, and this is like 8.5 inches. So we're talking about the mean difference in heights. So that's the follow-up question there that says, what does the result suggest about the two means? Someone try to tell me what this tells me in words. You had to write a sentence about this. What would your sentence say?
Supermodels are somewhere in between those two numbers.
Supermodels are between 5 inches and 8.5 inches
It's
tall?
taller than.
Ah, taller. Okay, there you go. So supermodels are somewhere between 5 inches and 8.5 inches taller than non-supermodels? I like that, let's write that down. Supermodels are on average, because we're talking about means, right? 5.1 inches, I'm trying to 1 decimal place, to 8.5 inches taller than women who aren't supermodels. That's the only reason the rest of us aren't supermodels, is we're too short. Women who are not supermodels. How do we know they're taller?
Positive.
Because my interval has positive numbers only. Positive numbers only, which means this number is larger than that number. So the positive difference is that it's this much higher to that much higher. If they were shorter, which would not make sense for supermodels, but if they were shorter, these answers would have been negative. This interpretation is crucial. Coming up with the interval is one thing, but knowing what it means is the important part. Yes, Christina.
Why wouldn't you say like how you said before, since there's no zero in it? Aren't you saying something like that would be?
Well, I could. So before I wrote this conclusion, I could say 0, my pen is dying, is not in the interval. So there is a difference. I could say that, but then the follow-up would be, well, how much of a difference? So your conclusion about a confidence interval is to describe how much of a difference there really is. So either there's no difference, or you're going to tell me how much of a difference there is. See what I'm saying? So there is a difference, and this tells me how much of a difference. And that's totally what you're going to see on the exam. Test the claim that there's a difference in here. Now give me a confidence interval to tell me how much of a difference. That's what we just did here. Or when you're working on your project, part 2, coming up pretty soon. Is there a difference between these two things that you're measuring? If so, how much of a difference? You can give me a confidence interval, tell me how much of a difference. Other questions? Getting this? Okay, let's move on to 133. Now we are in Ireland, and they did a contest for promotions for the successful and unsuccessful applicants. And some of the applicants who were unsuccessful in getting the promotion charged that the competition involved discrimination based on age. So we want to test the claim that the unsuccessful applicants are from a population with a greater mean age than the successful applicants. So the people who didn't get promoted are claiming, wow, you sure promoted a lot of young people. I think this is discrimination. This could happen in real life. Probably it did, based on what we have here. So they're going to actually test the claim to see if on average the whole population of people who were successful or unsuccessful really had a higher average age than the other group. What's the claim? And how do I write it?
mu1 is not equal mu2.
Is the claim that they're different?
They're greater. And,
Is it a not equal to, or is it a greater? You have a little fight? Uh-oh, I hear the graders outnumbering you, Hector. Do you agree with them?
Yeah.
Pen is not erasing.
switch pen here.
Example 5. mu1 greater than mu2, where number 1 is which group? Unsuccessful. We want to make sure we're clear, otherwise everything will get mixed up. So the unsuccessful, successful, and the successful. Oh, spelled it wrong. Make sure we know which one is which. We agree that's the claim? We have a greater mean age. That's my age 1. So what's my age 0? Equals. And they gave me all the information all lined up nicely there. So we can put that into what? Where are we going to put it? 2CMP test. We have 2 samples. It's a test about means. So we're going to put that into 2CMP test. And you guys know what to put in there? I'm assuming you do. No one's asking me any questions.
Would 2 just be the T?
How did you hear you said?
T?
Yeah, step 2 is the test statistic, which is the T.
Which is 1.68.
1.68?
And then would step 3 be P? Or
Step
less?
3 is the p-value or the critical values. We've only been doing p-values mostly. Did we agree with Kirsty's T?
Yeah.
And the p-value?
0.0504.
Which is equal to our alpha.
Alpha was 0.05? I don't think that's equal to alpha.
Oh,
It's a little bigger.
It's slightly bigger, ever so slightly bigger. Agree with that? That's slightly bigger than 0.05? All that matters is if it's bigger or smaller, not how much. This is greater than 0.05. Can you not read it, Kevin?
I could read it.
Oh, okay. I thought you were trying to read it.
I just got the wrong numbers.
Uh-oh. So double check that you typed it in right and that you picked the right claim here. So if you get everything right, the p-value's wrong, it's because you get this one wrong. Other people agree with these though, correct? You got outvoted there, Kevin. So because my p-value is bigger than alpha,
we failed to reject.
we fail to reject H0. So again, we failed to reject H0. Which tells me what about the claim? There's not enough evidence to support the claim. You find your mistake, Kevin?
No, not yet.
Support the claim that unsuccessful applicants have a greater mean age
Yeah, I got it.
than successful.
Thank you.
I'll make sure everyone writes down that conclusion before we answer the last question then. Questions on that conclusion? I'm going to say it out loud, I'm going to read it, and then we're going to talk about the last part. There's not enough evidence to support the claim that unsuccessful applicants have a greater mean than successful. So the follow-up is, based on our results, does there appear to be discrimination based on age?
No,
Why not?
because we failed to reject HO, and HO says that M1 equals M2.
We failed to reject H0, which says they're equal, and we didn't have enough evidence to support this. Now, when you look at the results, the sample means were different. The unsuccessfuls from the sample were older than the other group, 47 versus 43.9 years. But what we just found is it wasn't enough of a difference to say, you know what, there was discrimination. A lot of you get to this point where you can write out the claims and do the test and even write the conclusion, but you don't even know what the conclusion means. You just know how to write it. You need to be able to understand what it's telling you. So we don't have evidence of this difference. So there can't be discrimination if one group didn't have a different age than the other one. Questions? Okay, in our next 8 minutes, I want you to do example 6 on your own. See how it goes. I'll write it up here when we're almost out of time, yes. Oh, okay. That's example 8, example 6, the last one, whatever it is. I said 8 minutes, yes. So you're trying to do the test with the interval as well?
Yeah, just the.
Okay.
This way, since it's
It means there's no evidence of a difference. That's what 0 in the interval means. So 0 means there's no evidence of a difference. It's the same conclusion. There's no evidence of a difference. So there couldn't be discrimination. If the two groups had the same mean age, there couldn't be discrimination. That one group was older. Yeah. So everyone's trying example 6 from scratch on your own? All 5 steps? If you're not sure what you're doing, check with your neighbor, check with me. Pretend this is an exam problem and your whole grade's hanging by this one problem. Now we're digging up skulls, this is fun. You done, Kevin?
I got it before.
But then,
No, he is 0 possible. I did it.
oh.
How many times do I have to catch you on that, Brian?
Every time I see a P greater than 1, you know it's wrong.
Okay, so we had this for step 1?
Yeah.
What do we get for our test statistic? I don't hear you.
Negative 3.55.
Negative 2.55?
3.55.
3.55, thank you. Our p-value?
0 plus.
0 plus? Because it was
10 to the
zero,
negative
zero,
one.
yeah, 0, something, right? Watch that scientific notation. Which means you should have rejected H0. Now, I want to point something out to you. While you guys were working, I was organizing my thoughts and I didn't really write anything for steps 1 through 4. But I wrote this out for step 5 before we even did the test. A lot of people say, well, Jill, my conclusion was so close, there was just one word that was off. Well, it turns out there's only 2 words that you need to put in there compared to what's going on. So either you do or you don't have sufficient evidence. In this case, we do have sufficient evidence. And because my claim was H1, I'm supporting my claim. This is always a do or a do not. This is either a support or a reject, depending on what the original claim was. Okay, so you should be able to do 9.1 and 9.2. When I see you on Wednesday, we'll be finishing chapter 9. Ready to prepare for that exam.